Hello, hello, hello. It is once again Bob's Hands and the previously hinted at and much awaited teardown of the Ozito 18-volt brushless PowerXChange drill driver. Let's get into it, guys. There's not really much to introduce about this drill. It's a drill. I'm just gonna get a battery. It's currently working. Got a little light there. Adjustable chuck. Torque settings. I love this thing. Seriously, it is one of the best things that I have currently in my workshop compared to the older version which used the brush motor, which I touched on briefly in my previous video. This one has so much more power. Like, there is no competition. If you are choosing between this and the brushed version, get this every time because it is awesome. Now let's take it apart. Okay, wow, this is surprisingly hard to take apart, and as such, I'm kind of scared to go any further than this. I think we can see all we need to from here. I want to still be able to use this tool in the future, so I'm going to stop here, and let's have a look at the components from the battery end. We've got our battery terminals, which go straight in to this mass of electronics here. We've got a control board. This obviously has a microprocessor in it. And then we've got an actual power board. So this handles the logic, so like the brains of the operation. And this circuit board handles the power, which is the brawn. This is what makes the motor turn. We can see we've got MOSFETs. There should be 6 of them, yeah, back to back. There's 6 of them in there on a metal heatsink spreader. And that is what drives the motor. Now, I didn't mention in my last video, but this is called an ESC, or Electronic Speed Controller, and that's what they use to drive these brushless motors. Now, we've got this trigger here, so that's just standard pretty much, with the direction selector. But on the back here, we have something that we did not have with our impact driver, or impact wrench. See these really thin cables? These are not designed to carry power to the motor. What they're designed to do is carry signals about the motor's rotation and location back to the speed controller. And that means that this motor is able to start from a dead stop. So you have torque as soon as you press the lever, rather than waiting for the motor to do a couple rotations and then having full torque. This is called a Hall sensor, or Hall effect sensors, and they use the magnetic field that the magnets in the motor have, and it allows it to locate the position of the motor so that the speed controller knows how to send power to the motor. It's a bit more complicated than that, but that's just the oversimplified version because I don't want to go out of my depth and say something that isn't true to you guys. But yeah, Hall effect sensors, and something else that I did say in my previous video which might not have had context was a thing called phase wires. And what they are the current carrying wires that go to the motor. So we've got our Hall sensor wires, which carry the digital signals from the location of the motor. The power wires, which are these thicker wires here, they carry the full current, which actually makes the motor spin. And there's 3 of them. There's always 3 for brushless motors. Sometimes there's 6, but that's very, very rare. And yeah, so that's just a cool little tip there. We got this LED which has snuck out of position, so I'm just gonna push back in there so I don't forget about it. Okay, there we go. Cool. So I couldn't take this clamshell apart, and I suspect it's because the chuck has to come off, the torque selector has to come off, and then, oh no, there's something weird with the clicking mechanism there, scary. And then this piece of plastic, this is not metal, this is plastic. I have been pranked. They made it look metal, it's not. I broke a little bit of it when I was trying to pry it away with the screwdriver. Where was that? I don't know, but yeah, it's not metal. Yeah, so that's like a full enclosure that goes all the way around the drill, whereas the rest of it's a clamshell. So this is actually holding the parts together, so I can't take it apart. But we still get to see cool stuff from here. Now, onto the motor. It's a brushless motor, as mentioned on the packaging. Where is it? Yeah, brushless. Now, what that means, more efficiency, longer lasting for the same battery. It has way more torque and power. So you can use bigger drill bits, drill into harder materials, and the drill will hold up longer. It's also got better cooling too, because the coils, which are the parts that produce heat within this motor, they have direct access to the fan, and they can get really good cooling, whereas in a brushed motor, the coils are actually spinning, but they're stuck inside a little casing, so there's not much airflow. It's pretty much better airflow, and also the fact that it can be physically bigger. The coils can be bigger for the same size motor, and those are the two main reasons why this is more efficient. Anyway, there's a look inside the motor. There is a label on the motor. Let me see if I can get you an angle on that. Yeah. No, unfortunately, we can't take this clamshell apart, so we're not going to see the full label. And yeah, honestly, something fun I like to do is just spin the motor a little bit, just because, like, it's just the engineer in me, the kid in me that just likes to play with spinny things. But yeah, there you go. So that's the drill taken apart. There's not much more to say. So let's put it back together. And you know what I was referring to earlier about having the like the physically larger coils? All of this metal on the outside here is directly connected to the motor coils, and having that extra metal mass means that it has more thermal mass, so it can soak up more heat before the motor overheats. So you can run the motor for longer and put more power through it before the motor starts overheating, compared to a brushed motor where it's a tinier amount of metal and it's a lot harder to cool it. So yeah, that's my ramble done. Let's put this back together so I'm not scared that I'm gonna break it. Ready? And go. Moment of truth, guys. Awesome. Oh, that's kind of a relief, actually. This was a lot harder to tear down and put back together. But we made it in the end, guys, so thanks for watching. Thanks for sticking around to the end. Hopefully you guys are enjoying these videos. I'm gonna keep going because there's lots of tools. So yeah, let's keep this going. If you like it, like and subscribe. Let me know future ideas for videos and stuff. And just in general, bless you guys. Take it easy.